This demonstration will focus on enterprise visualization for the mining industry, showcasing how unifying data sources can provide benefits for monitoring mobile fleets. The workflow is started by the mine planner, who looks at the overview of their enterprise and visualizes the situation across their entire mobile fleet. They reach out to the shift supervisor to take a deeper dive into the status of the mining trucks. They achieve a comprehensive view through consolidating data sources, such as sensor data, maintenance history, and engineering context, into a single unified view, providing them with an overview of different aspects of the truck. From this, the shift supervisor can make proactive, value-driven decisions at fleet scale. This will help to sustain productivity and profitability. Mobile fleets produce large amounts of data. A single haul truck in mining can have over 200 sensors, streaming data from subsystems like powertrain, electrical, and payload. With a large fleet of trucks to monitor, managing all this data becomes a challenge. Here, the mine planner begins their day and opens an overview screen for a high-level assessment across their mining operations in South America, allowing them to identify how their key KPIs are performing against their targets. Several events linked to their truck fleet stand out. They decide to drill down to further understand the situation. Clicking through opens an overall view of the entire fleet and all the tracked equipment used on site. They can view the variety of equipment types present, including loaders and drills, helping them understand the fleet's health at a glance, including utilization, fuel consumption, and associated work orders. Following the alerts, the mine planner drills down again to the identified truck. This brings up a view of the 4 Komatsu trucks, including detailed status of the vehicle's health, financial impact to using them, and operational information from those currently active. They can also visualize the crusher tons, productivity, and total shift payload of each truck. After looking at the data, they drill down further into Truck 101. Here, the shift supervisor sees the full details for Truck 101. Some of the data displayed doesn't just come from the truck sensors, but also from the maintenance database. By aggregating information across systems and having a community of data consumers contributing to the display, they can view an accurate digital representation of the truck. The left exhaust temperature is lower than expected, represented graphically both by the chart and the alarm symbol, bringing attention to the potential issue and its impacts on other major systems of the vehicle. The shift supervisor knows that uneven exhaust temperatures and boost pressure variances are early indicators of combustion inefficiency or air leaks, both of which increase fuel use and shorten engine life. By applying anomaly detection models, they can filter out startup and idle noise to pinpoint specific issues. This enables early maintenance action, optimizes engine performance, and prevents costly failures, all achievable by viewing this advanced analytics data in context to the full details of Truck 101. Exploring other details here, they can see suboptimal oil pressure and uneven exhaust temperatures, which are common early signs of rocker arm failure, often leading to injectors misfiring or not firing at all. By monitoring these signals, the shift supervisor detects the issue early and can plan for maintenance before failure occurs. Eventually, this will deliver up to 70 extra hours of production time, over $170,000 in parts cost avoidance, and save significant diagnostic effort in identifying the root cause. Transmission failures are some of the hardest to predict, and once they happen, the team may only have minutes to get that truck off the haul road. By monitoring transmission slip, lockup slip time, and oil temperature, the shift supervisor can detect early signs of failure. Because the underlying systems are integrated, when these indicators spike, an alert is raised so maintenance and dispatch can act immediately. This proactive approach has prevented major production losses and saved over $120,000 in parts per event, avoiding costly recoveries and haul road disruptions that can last hours or even days. Additionally, this system is helping the shift supervisor to move from time-based maintenance to condition-based insights, such as for air filter blockage monitoring. Normally, filters are swapped at every service. However, by monitoring filter pressure, with 6.5 kPa set as the high limit, they can safely extend service life by 1,000 to 1,500 hours using the data to guide activities. That means saving $4,000 to $6,500 per truck each year in consumables, and it's an easy, low-impact way to introduce condition monitoring into the workshop. Lastly, the Shift Supervisor opens a dashboard that provides a view over the truck schematic and 3D information. This 3D model is underpinned by CFIHO's engineering standards, adapted to their needs and in accordance with attribute class library definitions. Here they can view recommended fixes and procedures from the service manual, helping to speed up root cause analysis and work order generation, significantly reducing the maintenance and reliability research time. With Connect unifying sensor data, maintenance history, and engineering context into a single lens, the Shift Supervisor can shift from reactive firefighting to proactive, value-driven decisions at fleet scale. The result is safer operations, higher asset availability, and measurable financial impact through avoided failures, extended component life, and targeted maintenance windows. Just as importantly, the approach is repeatable. The same analytics, alerts, and digital twin context can be applied across sites, models, and OEMs to standardize best practices. With clear line of sight from anomaly to action, the team closes the loop faster, turning insights into work orders into uptime, and uptime into sustained productivity and profitability. That concludes our demonstration on enterprise visualization for the mining mobile fleet. Thank you.